Okay, so what we'll do now is we'll ask the, like we did in the morning or earlier session, if the speakers could sit at the table and use the microphones, and then we can have a discussion section, question and answers. I have a question for Sophie and Alex. So it looked like you had some data gaps in comparing your deployed sensor and then what the MLR output said. I was wondering if you've been able to constrain, like, have you figured out when seasonally you need to deploy this in order to capture the best, or to make the best model? So maybe those of us might want to take a similar approach. Can you advise us on what type of variability you would recommend capturing?
So we only have both of the measurements, or we only have channels measurements for that July period and that December period. So we would only be able to say something about the summer and the fall. And we did do some analyses to test whether you could only measure part of the tidal cycle, but it seems like you need to measure the whole thing to get a good estimate of the flux over that tidal cycle. So I would say you need to have it there all the time, or a significant portion of the time.
Okay. So I think we did a kind of series of analysis. One interesting result is that I think is that if there's no episodic events, and then if the tidal cycle is pretty much predictable, then the chance you get your carbon flux right is pretty high by taking bottle samples or MLR method. The method is a little bit shaky when there's a episodic event. You know, groundwater intrusion, that's one example, storm, events. And that is the time actually the sensor really can capture what's going on. But I guess we just don't have much of an idea how much those episodic events actually contribute to the overall fluxes. So I think the model, at least to me, is doing reasonably well for predictable events. You know, tidal cycle over, every day, every month, yearly, but at the boundaries of episodic events is not doing very well. So.
I'd like to add something.
Sure.
For DIC, so the majority of the fluxes that we have seen are in the summer. So if you do want to get, say, there's like 70%.
No, it's 40% in summer, 30% in fall.
Okay, then, I mean, if you wanted to get 70% or something like that, you could go out just in the summer.
Okay. Other questions? Oh, yeah.
How portable do you think the parameters in the MLR method, how portable do you think the parameters in the MLR method are to a different estuary? So you did Stage Lot Pond, but if we went to a different East Coast salt marsh, do you need to retrain the method each time? And if so, how many sort of bottle samples do you need to retrain it?
That's exactly the question we start to, when we start this method, that's what the question we ask ourselves. I think the answer is, I wouldn't say it's a complete answer, but the experience tells us that you have to train your model from system to system. Even within the same system, my MLR between 2012 and 2014 is slightly different than her MLR, just slightly.
2015.
Yeah, because her has 2015 data in there. But the good news is actually I don't know whether it's good news or bad news. We have to consider the water flux very well. I think we did some error analysis in terms of how much uncertainty would be if you get your DIC concentration wrong. That effect is much less than if you get your water flux wrong. And that is a big concern for a lot of this previous estimate, which is don't really base on hydrodynamic water flux modeling. We do, but even with that, we still cannot figure out at this moment how much that going to contribute to the overall flux. But that's our next step, want to quantify that.
Hi, thanks for the great talks. Andrea Fospender over here. I had a question about the work Alec presented about the buffer factor changes. When you looked at the alkalinity export, was it carbonate alkalinity or total alkalinity? And did you think it was any organic influences or was it all non-organic?
Yeah, so there is some organic alkalinity. We have some organic alkalinity samples. I think we found there was, in the summer when there was the greatest organic contribution, there was maybe 5 to 8% that was non-carbonate alkalinity.
I wanted to ask the two of you another question. Sorry to keep picking on you two, but I was wondering if you tested any other models at all, other linear models, or if you played around with the parameters all that much with what you did end up using.
We didn't test any other models.
I thought about some other model, but eventually we think this is more related to the in-situ sensor we actually deploy. There is a model I have in mind, which is using it's not a linear model though, but it's empirical, but it's more using power analysis, some statistical method, which I don't really understand too much. But once again, back to the question, we did some analysis. So right now the model pick up about 74% to 90%, some variability out there. So if you say there's a 30% miscalculation of your of your DIC concentration, that actually only translate less than 10% in your net flux calculation. So once again, it's relatively less sensitive to concentration. So that's one of the take-home message we have is, we need to get our hydrodynamic right. Otherwise, this is not going to be very accurate.
Thank you. I have a question for Mathilde. I had not heard of subterranean estuaries before, and I'm curious what sets the circulation time scale in there. Do they have a tidal circulation, or is it much longer term?
There are tidal circulation. In this place, the groundwater transit around 50 days from the inland aquifer to the ocean. So we have time to biochemical processes. But here, the results are in June, when the snow has melted, so the recharge is really high, so we have high fluxes. So I guess at the end of the summer, it will be more slow. Par the temps slow.
Yeah, I had a question for all three of you. It had to do with interannual variability. So we've had 2 or at least 3 really wonky years of really dry and then really wet. And I'm just curious, are you in your data sets, have you been collecting it between, for example, last year and this year, which I think are very different from a hydrologic perspective?
All right. I think Sophie being so polite. But I think Sophie's data has, originally we have, we want to add in a couple of years together to look at the interannual variability. One result I remember, if I correct me, I'm wrong, is that the water flux is so different from 2013 to 2015. It's because 2015 is a wet year, I believe, or is it dry year? I forgot which one is which. But that totally shifted your DIC flux. Not entirely, but at least for the couple of important months, like the summer and fall. And I think that even, I mean, not just the magnitude, some of that is the sign of it changing. That's, but I guess we didn't actually quantify that much. But it's one of the, I think with the larger issue, we miss the episodic events. We're gonna miss quite a bit. I mean, we don't know actually. So, but for a limited number of days, we do have episodic events. It seems like it's quite a bit flux.
Okay. I have a question for Mathilde. My question is, I look forward to seeing your poster. I was wondering if you could give us a preview of some of the results between you said you deployed some FDOM sensors, or you have CDOM measurements and you have stable isotope measurements. And I was wondering if you could just give us a sense as a preview of how good you're able to correlate those two types of organic matter qualitative information.
Yes, we used optic and isotopic measurement approach, and the CDOM can give us good result to the composition of organic matter. If it's a proxy, kind of proxy, and we can say if we have high or low molecular weight on the organic matter, if we have humic or fulvic acids. And the isotopic measurement, here we use it as to confirm our CDOM result, that we have in fact a lot of presence of terrestrial organic matter from the organic horizon. So this organic horizon has really a role and impact in this place. And now the question is this organic carbon can reach the ocean, because there are a lot of biogeochemical transformation and trapping with iron. So currently we guess that this organic horizon is just trapped in the sediment, but not the marine organic carbon which reach subterranean estuary with the seawater. This marine organic carbon is just flushed out to the system. So that's previous results I can give.
Any final questions for our speakers? Great. Let's thank our speakers.